do today is work at converting, utilizing degrees, minutes, and seconds in terms of calculations. So let's take, for example, I've got an angle of 320.263 degrees. I want to convert that to degrees, minutes, and seconds. So obviously when I look at this, I got 320 degrees as full degrees. So I know when I complete my answer, I'm going to have 320 degrees. Now the 0.263 degrees is a piece of a degree, so it's not a full degree, and I'm going to break that down into how many minutes that would have. Now the biggest thing right now we need to know is that we know that 1 degree is equal to, let me write this so I can see it, 1 degree is equal to 60 minutes. 1 degree is equal to 60 minutes, so that's going to be my conversion factor. It's going to be 1 over 60 minutes, or 60 minutes over 1 degree, depending on how it's going to be utilized. So right now I've got a degree in my numerator, and if I'm going to convert this to a minute, I got to have a degree in my denominator. So I'm going to take this and say 60 minutes is equal to 1 degree, so we can see now that the units of degrees cancel. And if I do this math, if I do it properly, this is going to be equal to 15.78 minutes. Now that means now I can start filling in my chart here with minutes, and then further breaking that into seconds. So now I know I've got 15 full minutes, and I've got 0.78 minutes. We know that there are 60 seconds is equal to 1 minute. So now I can convert this to seconds. So the first thing I will do is do this multiplication of 60 seconds over 1 minute, and we can see now that the units of minutes will cancel, and when I do that, this becomes 46.8 seconds. Now in this case, we're not going to take it any further down than a second, so we can take this and just round this to say 47 seconds. So my final answer would be 320 degrees, 15 minutes, and 47 seconds. We got to get used to the notation that we use. I'm going to say 15, a single little hash mark there indicates minutes, and 47 have a double hash mark to indicate degree or seconds. So that's the type of question, if you're looking at the homework that I assigned, that would relate to problem number 65 to 70 in the homework. So then we'll do the other type. So this time we're going to take, like we have as the answer, like we just did on the previous problem. Let's say we've got 20 minutes as an example, 13 minutes and 27 seconds. So if we have that, that means we got 20 degrees, 13 minutes, and 27 seconds. So just getting the notation of the double hash marks indicating seconds, single hash mark is going to indicate minutes. So I know my answer is going to be 20 point something degrees, so 13 minutes, I'm going to have to convert back to a portion of a degree. Let's write that again, 13 minutes over 1, and I'm going to convert that to a piece of a degree, and that's where we're going to use the final unit, 1 degree. In doing this math, we're going to get an answer of 0.2166 degrees. So at this point, we're looking pretty good there. Now I've got this 27 seconds. I'm this by 1 minute is equal to 60 seconds. So my unit right now will be in minutes, but I need it to be in degrees, so I need to do one more conversion, just like we used up here to convert that piece of a minute, in which we identified the relationship of 27 seconds. It's about a half a minute, but so we want to go through the proper math and get everything as best we can. Now I have to take that minute and convert it to a degree, and like we used before, we have 1 degree over 60 minutes. And this looks like converting from seconds to minutes and then minutes to degrees. So this involves a little more work. This appears to be 0.0075. And I got 2 pieces of a degree right here is the 0.2166 and also the 0.0075, and those are both pieces of a degree. If I add those 2 pieces together, we should get 0.022417. So when I look at my final answer, I know my answer is going to be 20 degrees and a couple pieces, 20.22417 degrees. So I took the 2 pieces of a degree and added the 2 pieces together to get my final decimal value for a degree. And I'm going to round the answer to 20 point, let's say if we want to do just 2 decimal places, it would be 20.22 degrees. So that would be a good answer for that. So you see in this case, we're starting with 20 degrees, 13 minutes and 27 seconds, and converting that to a decimal value of the degrees. So that involves a little more work, a little more understanding of the conversions. And if I assigned problems, I think I did, that we assigned 59 through 64, and all of these work under that category. So all of 59 through 64 we'll do in this fashion. I got one more that you're going to run into, that you'll make sure. I think we got to like problem number 69. If you're looking at that problem, you want to look at it real closely. As you look at that problem close enough, I'm trying to find it, I just don't have it, so I'm going to make up another one instead. But if you look at that problem, it might, I think my memory says 0.3, or yeah, 0.355. I'm just going to make up another one. But problem number 69 is a radian and not a degree. If you look at all the problems prior to that, like 65, 66, 67, 68, they're all degrees. But 69, I don't know what it is, but I'm going to make up one that just says 3. And that is not a degree, it is a radian. So keep in mind, remembering that a radian does not have a degree sign, and a degree does have a degree sign. So we know that when they just have the answer number 3, or whatever the number is in the problem, it doesn't have a degree sign, so we know that is a radian. So I know this is a radian, so I have to use the conversion factor of pi over 1/8, or I got to convert that to a degree, and I just did it wrong. So we got to multiply by the conversion factor of 180 degrees over pi to come up with that and convert that first to a degree. So like on 69 and 70, I believe they're both radian values that you have to convert to a degree. So we do the 3 times 180 and divide that by pi, and we get an answer of 171.887 degrees. Okay, so I got kind of a big value. I probably shouldn't have used 3, but I did. And it should make sense because we know on our circle at 180 degrees that's equal to pi. So 3.14 is approximately equal to pi, and we know that 3 is just a little bit less than pi. So it would be 170 plus degrees. So it does make very logical sense. And so at that point, I know I've got to convert this to, again, maybe to a degree, minutes, and seconds again. So when I do this, I know I've got an answer of 171, and now I've got 0.887 a piece of a degree, and I need to convert that to minutes. So I know that 1 degree is equal to 60 minutes, so the conversion factor we'll use would be 60 minutes over 1 degree, and that will convert to 53.22 if I did this math correctly. So that would be in terms of minutes. So as I break this down, I'll know I have 171 degrees. Oh, I have then 53 minutes. And now we're going to calculate the seconds. So now I have 0.22 minutes. I'm going to convert that to seconds. So again, I know there are 60 seconds to 1 minute. The units of minutes cancel. That will equate to about 13.2 seconds. So again, this isn't rolled in there equally, so we're going to round that to the nearest second. So we're going to say that's going to equate to about 13 seconds. So if we do this, indicate our work here, I got 171 degrees, 53 minutes, and 13 seconds. If I use the proper unit notation, I got 171 degrees, 53 minutes with a single hashtag there, or single click, whatever that thing is called, and the double click for the seconds. So